All right, so a bag contains 4 red, 3 blue, and 5 yellow marbles. 3 marbles are drawn one at a time without replacement. Determine the probability that the order in which they are selected is blue, blue, and red. Now in this case, order matters. So that means we're looking at permutations. And the probability that we're going to get blue, blue, and then a red is going to be the probability of each event happening divided by the total number of events. So the total number of ways that these events can happen. So the total number of ways you can get a blue, and then a red divided by the number of possible outcomes when you draw 3 marbles out of the bag. And so what this works out to be, and I'm going to show this 2 different ways. So the first part here, probability of 3 choose 1. So this is if we got 3 blue marbles and we're going to choose 1. There's 3 ways we can do that. Then after we choose the first marble, there's 2 blue marbles left. And so there are 2 ways we can choose that second blue marble. Then we're going to draw out a red marble. We have 4 ways that we can draw out that 4th red marble. So that's why we end up with 3 times 2 times 4 over, and 12 choose 3. So this means that the number of ways that we can choose 3 marbles given a total of 12. So that'll be 12 times 11 times 10. And if we cancel out here, this is going to be 3, 1, cancels out again, and this will be 5 and 1. So we end up with a total of 1 out of 55. Here, we're going to select 2 blue marbles and 1 red. So here, order is not important. And the reason it's not important is we could select a red, then 2 blue. We could select a blue, then a red, then a blue, etc. So out of that way, there's 6 ways that we can actually choose those marbles. So the way we calculate the probability of that is 3 choose 2, so that means that the way we can draw 2 blue marbles out of 3 times 4 choose 1, which is the number of ways we can pick the red marbles. And then we're going to divide that by 12 choose 3, the combination of 12 choose 3. So this is going to be 3 times 2 times 4 again over 12 factorial over 9 factorial, 3 factorial. And if I go up here, this is going to be equal to 24 over, and this will simplify to be 12 times 11 times 10 over 6, which is 3 times 2, the 3 factorial. And the 9 factorial will cancel out the 9 times, etc. So this cancels out, so that becomes 2. So this is equal to 24 over 2 times 11 times 10. And we can simplify that, so that goes into itself once, and into 12 and 5 and 6. And so this is equal to 6 out of 55. And so since order doesn't matter, there are 6 more ways that we can select 2 blues and a red, as opposed to when order matters. And so that's why we are 6 times more likely to draw the 2 blue marbles and 1 red than in the case where we say we have to draw blue, blue, and then red. So the probability is 6 times greater. If we are selecting 3 objects from a group and order is important, there are 3 factorial, or 6 different ways we can select the same 3 objects. Therefore, if order does not matter, as in part B, the probability of the event occurring increases by a factor of 6 in this case. So when we're talking about three objects. So that explains why this part B is 6 times more likely to occur than part A. So next question, a pair of dice is rolled. What is the probability that the sum of the numbers rolled is either an even number or a multiple of 5? Now in this case, we have non-mutually exclusive events. Therefore, the probability of an even or a multiple of 5 is equal to the probability of an even plus the probability of a multiple of 5 less the probability of an even number and a multiple of 5. And so I'm going to go down here and explain what we mean. In yellow, I have all the even numbers that could possibly roll by 2 die. So if we roll, the blue die is die number 1 and the red die is die number 2, then all the yellow ones are the examples of where we have even numbers. So that means there are 18 out of 36 possible events where we have even numbers, if you add up all the yellow squares. Now for multiple of 5, so we'll go back down here. There is a multiple of 5. So 2, 3, and 4. So we can roll 5 4 different ways. We can also roll a 10, another 10, and another 10. So there are 3 different ways we can roll a 10. So there are 7 ways that we can roll multiples of 5s out of the 36 possibilities. So the probability of that is 7 over 36. And going back to our chart below, you'll notice we have to also consider then these events, the 10s, are repeated because this is non-mutually exclusive. You can roll even numbers and a multiple of 5. So that's where you roll the 3 occasions where you roll a 10. So what we have to do is we have to subtract off those 3 events out of the 36. So this is 18 plus 7 is 25 minus 3 is equal to 22 out of 36, which is equal to 11 out of 18. So really, part B should be asked even before you attempt part A. Always ask, is this mutually exclusive when you are trying to identify whether the probability of an event happening, especially when you see the word or, because if they are non-mutually exclusive, then you have to subtract off the probability of both events occurring. If they are mutually exclusive, then you just add the probability of the 2 events. The likelihood of both events happening when it's mutually exclusive is 0, so we don't have to subtract the probability of both. Right, so let's compare this question to the last one. And in this case, we're told that when we roll a pair of dice, we're asked what is the probability that the sum of the numbers rolled is either a 7 or 11. So the first question, when you see that or, is are these events mutually exclusive? And so when I look at this chart, you can see that it is not possible to roll both a 7 and 11. You either roll a 7 or 11. So since they are mutually exclusive, the probability of 7 or 11 will be equal to the probability of rolling a 7 plus the probability of rolling an 11. So the probability of rolling a 7, well, there are 5 six different events where we can roll a 7. So that's 6 out of 36. Plus, down here, there's 2 ways we can roll an 11. So this is equal to 8 out of 36, and that reduces to 2 over 9. So in other words, the probability of rolling either a 7 or 11 is 2 out of 9. Now, going back to this question, are these events mutually exclusive? Since both events cannot occur, as in the case of non-mutually exclusive, when you have 7 or 11, if they were non-mutually exclusive, we would have to subtract away the probability from this where they both occur. But since the probability of 7 and 11, well, that's equal to 0. That's minus 0 because this is impossible. You cannot roll a 7 and 11. So it's basically the same formula as before, but the probability of rolling a 7 and 11 is 0. Next question. Mr. Lamb has 3 children, 2 girls, Sue and Karen, and 1 boy, David. So after each meal, 1 child is chosen at random to wash dishes. Determine the probability that 1 boy and 1 girl will wash dishes after lunch and dinner on Saturday. So here's our tree diagram, and it's really important that you maybe try drawing this when you answer all problems like this. So the key here is, what is the probability that 1 boy and 1 girl will wash the dishes? So at lunch, if they're drawn from random, we can have a boy or a girl or the other girl. So this is Sue and this is Karen, or vice versa. And this is David. So at dinner, again, the names are chosen by random. So David could end up doing the dishes again, or it could be one of the other 2 girls. And so there are 9 possible outcomes. And as you can see, here's a case where a boy and a girl will have to wash the dishes. Here's a case where a boy and a girl have to wash the dishes. And here's a case where a boy and a girl have to wash the dishes. So out of the 9 outcomes, the probability of 1 boy and 1 girl having to do the dishes is equal to 4 out of 9. The last question, and we could have done the first question like this as well. We have 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is drawn and replaced. The other paper clip is taken from the drawer. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second paper clip is blue? Well, for the first one, there is probability of red, then blue, is going to be equal to the probability of red times the probability of blue. Because there is replacement, we're not going to consider that. So the probability of the red being drawn is 3 out of 12 times, now the red paper clip is replaced again, so there are still 3 red paper clips in there. So the probability of then drawing a blue will be 5 out of 12. And so this will reduce to 1/4. So we end up with 5 out of 48.